Zero is my hero. Now, in the context of this course, we're not going to spend a lot of time working on this particular aspect. I'm just sharing with you that in the development of understanding, students have to take some time to understand the idea of making zero. And doing that in many contexts and with manipulatives, as you're about to see, is very important. So depending on your context, depending on your experiences of kids, here might be a way. Imagine a temperature situation. If it's 21 below zero, temperature, negative 21, and you increase the temperature by 21, that is, add 21, negative 21 and a plus 21 combine to make zero. That might be one way to help students understand the idea of making zero. Or in the context of golf. In golf, you are each hole that you play, like hole one has a par four. That is, the expectation is, the standard is that you should be able to accomplish that hole, put the ball in the hole in 4 strokes, 4 strikes of the ball. The second hole is a par five. You get 5 strokes, 5 hits of the ball to get the ball in the hole. Now, if you can do a par four in only 3 strokes, it's called a birdie, and your score is a -1 because you're one below par. Or if you get a bogey, that means in a par four you needed 5 strokes, that's a +1. So in golf, you can get -1s and +1s. And so, like, notice here, Arnold Palmer here took 3 strokes on a par four, so he's a -1. And then he took 5 strokes on a par five, so he's still at a -1. But then look here, on a par four, it took him 5 strokes. So his -1, a birdie, par, still at -1, and then bogey, a +1. His score goes back to 0. -1 +1 makes 0. So maybe golf would be a context by which students could make sense of making 0. Or money. You could say on a ledger, an accounting sheet, you could have owing $10. That would be a -10. Getting $10 would be a +10. And if you paid your $10 to who you owed, you'd be back to 0. So -10 plus 10 makes 0. There's lots of ways, lots of contexts, well, maybe not lots, but there's at least several contexts by which students can make sense of making 0. And students need that experience. As you'll see going through this module, making 0, 0 is my hero, is a thing. Well, how do we do that with manipulatives? Well, here's what we're going to do. It's important for students to learn how to make 0 flexibly and flexibly make other kinds of numbers. So for example, we're going to use chips. Now, you'll see later on in this module, we have a virtual manipulative. There's going to be chips that represent positive quantities and chips that represent negative quantities. In this case, this clearly, I hope, is a positive 1 chip. So in terms of quantity, I would argue that I have 1 represented on this screen right now. Why is it not clicking through? There it is. Now I have 2. Now I have 3. So together I have 3. Now, if I combine +3 with -3, now here's how we're going to represent a negative quantity. Now, from the previous experiences, maybe this is like in the context of temperature, maybe it's in the context of golf, maybe it's in the context of money, but negative quantities exist. And so when we put together negative quantities and positive quantities, what they create is 0, because a +1 and a -1, like a birdie and a bogey, or owing and getting, or temperature, whatever it is, students need to have this idea that combining 3 positives with 3 negatives represents 0. So what you're looking at on the screen is a representation of 0. Now, when kids are really, really little, like 2 years old, 3 years old, 4 years old, something like that, and you show them money, suppose you showed them a quarter, dime, and a nickel. They might look at the quarter, dime, and nickel and go, oh, look, 3 monies. There's 3 monies. But we know a quarter, dime, and a nickel represents 40 cents. Kind of likewise here, you might look at this screen and say there's 1, 2, 3, 4, 5, 6 chips. And there are 6 chips on the screen. But what do those 6 chips represent? Just like 3 monies can represent 40 cents, these 6 chips represent 0. So 1, 2, 3, 4, 5, 6 chips represents 0. What if we added another chip? So 1, 2, 3, 4 positives and 3 negatives, but a positive and a negative make 0. A positive and a negative make 0. A positive and a negative make 0. So what I have here now representationally is a representation of 1 again. That's the flexibility part. You can represent 1 lots of ways. One single chip represents 1, but also 4 positives and 3 negatives represents 1 because of these 0 pairs. So 1, 2, 3, 4, 5, 6. I have 0. Representationally, I have 0 on the screen right now. And if I add some more chips, I just made another version of 0. So you have to keep in mind that these chips are going to be representations of quantities. There's positive quantities and negative quantities, and teachers need to spend time with kids making sense of just negative quantities in context and what they represent before we get into addition, subtraction, multiplication, division. So we're not going to take a ton of time on that in this class. I want you to be aware that theoretically, in our brains as we move forward, this idea of representing quantities with chips and understanding about making 0 with a positive and negative is part of what we've already established moving forward.